in Central Time. Good morning, good afternoon, good evening, good night, wherever you are around the world. Thank you all for joining us. Give a second for everybody to file in. Hello, hello, so many people. Always a pleasure to see y'all. This is runZero, our episode C. Last month was episode B, which was vertical tab for the ASCII control character. C is form feed. C is form feed. So, eject a new page. It would almost be fitting if that were the New Year's Eve one. Start a new year, turn a new page. But alas, it is the November episode. um, I am joined today through the miracles of technology by Tom Sellers, who is a principal researcher here in the Austin area, and by an even greater miracle of technology all the way from upstate New York, Blaine Smith, who is a researcher here also at runZero. Thank you, gentlemen, for joining us. We have quite the episode today. First off, we're going to be talking about discovering non-IP addressable OT assets, which is quite a mouthful, but never fear, all will become clear. And then after that, Blaine is going to take us through the pros and cons of the ProConOS protocol. And yes, I've been waiting to say that for I came up with that and was like, oh, that's perfect. Going to say that immediately. And then Blaine is going to continue on talking about how OT convergence is not just in industrial environments, but beyond the realm of the factory. And Tom will send us off with November's rapid response roundup, which there's quite a bit. And then be sure to stay tuned because there's also an exciting contest for the runZero Hours 1 year anniversary. Very exciting. So be sure to stay tuned for that. There are prizes. So to lead off, let's talk about discovering non-IP OT assets. So OT, and this is something that we've talked about a lot over the past couple of years. OT and IT are converging. And for those of you who maybe aren't familiar with the term, OT stands for operational technology. There's a lot of terms that sort of float around. There's OT, there's ICS, there's SCADA. OT is operational technology, ICS is industrial control systems, and SCADA is supervisory control and data acquisition. They're not synonyms, but they all kind of refer to this concept of computers that control things in the real world and have physical effects. So not just IT, not just manipulating information, but OT, operational technology, controlling operations. And for the longest time, OT was this sort of island unto itself. It had custom protocols for a long time before it was even custom protocols. You had to physically be present. I'm always reminded of the Jacquard looms, which were controlled by a punch card, and they could weave things, and that's several hundred years old now. That's technically operational technology, but we're talking about how factories would be automated, right? One human didn't have to sit there and do things. They would have maybe a spinning drum or a timer, and then it moved on to things like ladder logic, where you could actually, control things with little switches, and they would, create patterns and things like that. And as these factories became more complicated and more integrated and more managed, the management of these devices, these individual devices, became more and more potentially centralized. And so it used to be that you would have a control room in the middle of your factory, or in various places around your factory, and they would have wires going to various places, and tubes and dials and things, and they would show the status of all these devices, all the individual components in your factory. And as time has gone on, this has gotten more and more digitized and more converged with IT. And so what I mean there is that these devices used to speak protocols that were specific to factory, to these kinds of devices, or to this manufacturer or something like that. But we've seen this enormous convergence of OT and IT, because IT protocols are commodity hardware, commodity software, much more easily available to customers and consumers, much more easily trained, in some ways more reliable, not always. And so you're seeing more and more of these protocols running on top of the TCP stack, the TCP IP UDP stack, which is great. But so now there's almost become this layer of abstraction where you see this beautiful control room here, and this is from an electrical company in Germany. You see this beautiful control room where they're monitoring all these devices, and it's super cool, right? It's super beautiful, but you kind of forget that, or maybe you don't quite remember that at the end of the day, it's really these devices, these sorts of large industrial devices doing things. And so these devices are pumps or valves or motors or sifters or various other things that are spinning and poking and prodding and doing whatever it is they do to accomplish this industrial process. And these devices, these devices do not speak much of anything, right? At the end of the day, they are little electrical devices, and they are connected to systems that are then connected to other systems that are then connected to other systems, and eventually you get to that control room. It may not be that many layers, but the point is, what you're necessarily talking to in the control room isn't this device specifically, it's a controller for this device, right? You're not talking to the gears and things like that. You're talking to a controller for that device. And so for a long time, those devices were speaking custom protocols, so they had custom wiring or whatever, and they still do. But management has moved more and more to IP-based technologies. And so when you go in and you want to discover things in a factory or in an industrial environment, we're going to start discovering IP devices that are connected to an IP network, that have an IP address. And so we're going to go and we discover these devices and we find out what they are. And what we often will see is that we're not seeing past sort of that supervisory layer, right? Or maybe even past that coordinating layer. We will see the coordinating computer, we'll see the computer that's talking about the process or managing these other devices, but there's other devices that we might want to see. I personally really love asset discovery, and I take it personally if I don't discover everything I possibly can. I'm actually quite annoying at parties about that sort of thing. So what we want to do is we want to see as much as we can and dig down as deep as we can into these other devices that are still technology. They're still computers. They're still speaking a network protocol. They still have some intelligence to them, but they're not necessarily speaking IP. Or if they are speaking IP, they're not connected to the IP network that we are talking to, right? And so to give you an example, this is an Allen Bradley chassis. Allen Bradley chassis sounds like a band or an album name, Allen Bradley chassis. But this is a device, and this was bought, I think they're owned by Rockwell now. But this is a ControlLogix chassis. And you can see there, you've got lots of individual little cards. So you've got a PLC, which is a programmable logic controller. And a PLC is basically a ruggedized industrial computer where the intelligence is that controls sort of a piece of the overall process. And then you've got lots of other little cards in there, and then it's very modular. So these cards are things like communications adapters to talk to different networks, but also things like DC power inputs or outputs or controllers or things to communicate with other chassis. But the point is that it's not just the PLC. There's only one piece of this that is connected to an IP network, potentially. And it may not be the piece you think it is either, which is always fun. So how do we discover these devices? Well, there's lots of protocols. There's lots of tricks and tips and cool things that we can do to discover IP addressable assets, and we do a lot of them. And for this one, we're going to focus on, just for the purposes of example, a suite of protocols called SIP and Ethernet IP. And to get it out of the way, SIP is a CIP, not SIP. It's not the session initiation protocol from VoIP. It's the Common Industrial Protocol, which is also not the SIP that's used for certifying other things. So there's a lot of acronyms, which is great about our industry. So to discover these devices, that device that I just showed you a picture of, it speaks a protocol called Ethernet IP. And that is, IP does not stand for Internet Protocol. It stands for Industrial Protocol. But the Ethernet does mean Ethernet, so at least that's good. But it's a little confusing because Ethernet IP is the industrial protocol on top of UDP, TCP, and IP on top of Ethernet. So it's Ethernet IP, it's TCP IP, IP Ethernet, Ethernet IP. It's really quite fascinating when you think about it that way. But Ethernet IP is a protocol that is used to communicate with industrial devices. And in this case, it supports, it's a pretty neat protocol. It's one of my favorites. I really love it. But it allows you to send commands and get responses back. And so as you can see here, this is a dissection of a Ethernet IP packet that is sending the command list identity. And I don't want to hold you in too much suspense, but list identity asks the device to list its identity. And so this is a response saying, okay, I'm responding to this list identity command. And it is, I am a Rockwell Allen Bradley programmable logic controller. My hardware revision is 20.11. My serial number is, whatever that serial number is. And I am a 1756L61B Logix 5561. This is all super useful because I can say, okay, what are you? I can ask the device to tell me. And Ethernet IP, a lot of times when you do industrial discovery, this is one of the most common protocols in use. You'll see this message can be sent via either TCP in a connected sense or via UDP, where it can you can do a broadcast, or you can just send a UDP packet and say, please send me back your identity, and you'll get a response back, and it'll say, I am, in this case, this device. And by the way, also, I'll leave it on screen for a second. If anybody wants to guess what the sender context, that's a not meaningless. It's a way of uniquely identifying a context. If anybody wants to guess what that says, real fast. Okay, all right. It says runZero with an exclamation point. That's our sender context. So I always love that. But this protocol is used to discover these devices. And so when I send this list identity request, I'm going to get back the device that is connected to my network. The IP addressable device is going to come back and say, I am this thing. And that's great. And so you can see here is an example. This is a IO link master from IFM Effector Inc. This is in our laboratory. And it's responding to, you can see here, it's responding to on port 44818 UDP. That's the Ethernet IP port. UDP, because I sent this via UDP, and I said, please tell me your information. And here's the information we got. And you can see it identified itself. It's great. It's super useful, but it's still not necessarily everything. And I want to see everything, as I mentioned before. So how do we see everything? Ethernet IP, when I send that request, it's only going to give me the response from the device that's directly connected. It's going to ask for, this IP address, 192.168.40.9, tell me what you are. And it did, which is great. So now, how do we go farther? Well, let's talk about SIP. So SIP, like I said, stands for Common Industrial Protocol. It used to stand for, when it was very first created, I think it was Command and Information Protocol, or maybe it was Control and Information Protocol, but then they backronymed it to Common Industrial Protocol. And so SIP is a abstract protocol in that it has multiple, it defines a set of objects and instances, and it's very object oriented. It's vaguely reminiscent for anybody of a similar vintage to myself. If y'all remember Corba, it's vaguely similar to Corba. I know Tom is probably, his eye is probably twitching now because I'm sure Corba was not fun for quite some time, but Corba was neat. So SIP defines a common set of objects and classes and functions on those objects and attributes of those objects. And you can say, okay, and each device will say, okay, I've got, say an object that describes this IP interface or an object that describes this connector for this motor or something like that. And then it defines this abstract way of saying, okay, I want to invoke this function on this object, this instance of motor object. And then SIP is this abstract protocol, but then it has different adaptations to different networking technologies. So you can see down here that Ethernet IP is the adaptation for SIP to TCP, UDP, Internet Protocol, Ethernet. But SIP also has adaptations for CompoNet, ControlNet, DeviceNet, and these are all different industrial networking technologies that are used in different mechanisms or different environments and different fields and things like that for different reasons. But for when you're talking IP or you're talking on an IP network, the adaptation is Ethernet IP. So Ethernet IP, or I'm sorry, so SIP gives us the ability to dig around. Oh, and sorry, and just, yes, so you can see here that SIP sits on top of, it is a first-class citizen of the IP TCP world, right? It sits at the same level as FTP and HTTP and SNMP and all those other things. It's not a distinct protocol in that sense. And then the adaptation of SIP to IP is Ethernet IP. So SIP lets you talk about objects and ask for specific instances and ask for pathing to them. And one of the objects that SIP has is called the connection manager object. And the connection manager object, drum roll please, I don't want anybody to be shocked here. The connection manager manages connections. So you can say, connection manager, please establish a connection on my behalf to this other object in the SIP abstract namespace. And so you can say, and then you can send messages to that across that connection, and it will be forwarded to other objects, and then the responses will be forwarded back to you. And it does the magic here is that it doesn't matter what underlying network technologies there are on the other side, right? So I'm speaking Ethernet IP, but when I ask for a connection to be established to beyond, into the great beyond, it might be speaking over DeviceNet or ControlNet or CompoNet or the backplane on a Allen Bradley chassis. So I can say, okay, Mr. Connection Manager, please open up a connection to this SIP address. And the SIP address each device has different, each address class has different ways of creating a path. But the path is basically, you can specify hops to get where you're going. It's almost like IP source routing. Again, if you're a similar vintage to me, everything I say just reveals that I'm getting older. But you can take that and you can say, okay, please speak, please establish this connection to this distant object and forward these connections along. And so the Ethernet IP, going all the way back, the Ethernet IP list identity command is defined as the equivalent of asking for a subset of attributes for the identity object of a device that speaks SIP. So I could get the same information, and actually potentially more information, that I would normally get from a list identity request if I instead established a SIP connection, said, please give me the identity object, which is, object one, please give me identity object, please get me the attributes of the identity object. And the attributes on the identity object are things like serial number and manufacturer, but they can also have, there's more things that can be on the identity object than can be returned in the raw Ethernet IP one. So you actually have to establish a session and get some more magic going on there. All that is to say is that I can say, please connect to this other object, or this other object that could be on another device, and connect to its identity object and ask that identity object for its attributes. And I can get those back. And by doing that, I can say, go to backplane address 0. You can see I'm talking to the SIP connection manager here, and I'm saying, send an embedded message, an embedded SIP message that says, get me your attributes to, in this case, backplane link 0. So link backplane 0, or I'm sorry, backplane 3. Backplane 3 is the fourth slot, using the example of the Allen Bradley chassis, is the fourth slot, because we start numbering from 0, because as all right-thinking people do, you should start counting from 0. And we request to forward that get attribute message to the device at that address, at backplane address 3. And the connection manager, for whatever device we're talking to, the connection manager will set up that connection and will forward that message, and it will forward the response back. And the end result of that is we get the ability to see the objects, or the devices in the other slots of that system, which is super cool, right? Like, I just love it. These devices don't necessarily speak IP. These devices are not something that we can see directly, but we can ask that system on our behalf to forward that get message, that get attributes message to us, or to that far end device, and forward the response back. And it's super great. And so there's lots of applications of this, of course. And SIP is not the only protocol out there, but this, for like I said, for the purposes of this example, SIP is the way to go to describe it. But there's lots of other devices that I'm really the whole team is really just digging into how to get far end devices to talk to us. So that has been really just such a fun project. I love it. But that is discovering non-IP addressable OT devices, which, again, like I said, was a handful or a mouthful. And with that, I would like to move on to Blaine, who is going to talk about the ProConOS OT protocol, which is from, as you can see, Phoenix Contact. And I'm sad that I already blew the joke about tell us the pros and cons of the protocol, but tell us the pros and cons of the protocol.
Yeah, so thanks, Rob. That was great. Yeah, just sort of following that story into what some of these other protocols actually are is Procon being one of them. We had done a previous segment. I can't remember what episode we were doing this on, but we covered the ATG protocol, and sort of as we're working with these different variations of OT protocols, we're going to keep doing this as we move along. So this time we're working on ProConOS, which, like Rob said, it's a Phoenix Contact proprietary protocol. They do have others. I think their more modern version right now that they've been working with is PCWorks, which I'm pretty sure we already have support for that. But this is an older protocol that they've used in the past. It's sort of like a group of an operating system and a programming language and an IDE, sort of all wrapped up into this whole branded ProConOS thing. Typically used for embedded operating systems for OT stuff. It actually does have support for extending the PC operating system, like Windows, to load plugins and extensions sort of like into that, because of sort of how it was built specifically, which we'll cover. Again, like by Phoenix Contact, traditionally used in like their PLCs, their HMIs, and sort of like their whole suite of devices that you can buy from them. Programs themselves are written in this multi-prog programming language. And like I said, it comes with like this IDE and whole environment. So it's a giant full suite of tech IDEs, sort of everything all sort of bundled up into one to make doing this much easier to build almost a
Yep.
decade or more ago at this point, which we can get into the
Yeah.
dates.
I
uh,
did talk. Yeah, we're old, right? I
yep.
said something about IDE to someone the other day, and I meant IDE hard drives, like integrated driver electronics hard
Oh,
drives, and
yeah,
they were like, "What are you talking about?" And I was like, "Never mind, never mind."
yeah.
But
Yeah,
yes.
we as programmers, we definitely hijacked that acronym
Hmm.
lately. Nobody
Hmm.
nobody rested the hard drives there. But yeah, so some of the highlights on the ProCon stuff, it was sort of based on this open platform communication, which is again sort of based off this OLE back in 1996 around Microsoft. The whole like thought of objects and working with object-oriented stuff. So it's very
Hmm.
centered around that, similar to like what you were covering with SIP.
Hmm.
Sits on top of standard TCP IP stack, so which is super awesome for us. We can trivially craft packets to do interesting stuff. But it's interesting because they do sort of sell itself as a real-time protocol, which traditionally you don't really see a lot of super sensitive real-time network traffic traveling over TCP because of the intended like error correction and just like the general
Hmm.
slower nature of TCP in sort of real-time systems. Um, but there are, some of the other promises that the Procon system gives, even within the OS level itself, is its deterministic nature.
Hmm.
So which comes with a lot of, safety guarantees on when you're interacting and sending data to these systems and across the wire. You can very well understand exactly what's going on based on the data that you're passing through, which is as software engineers, we would love deterministic everything. If we could, we could then predict the future at that point, right?
Exactly.
Um,
Exactly.
you know, and having it, it's all based on Microsoft's initial like
Hmm.
component object model. Again, being embedded in Windows has sort of allowed just the Windows OS to be able to be extended to being a client of the Procon
Hmm.
OS sort of system.
Yep.
And then it had, because of that, it can sort of act as like this gateway um, to sit in front of other devices that could be, its backplane, beyond that, like a
Hmm.
local LAN environment. So uh, I think you go next one. And so what we're doing with that at runZero is, again, because everything is sitting on TCP, we can speak that uh, very trivially. It's again, just sending this crafted info packet to a very specific port, and we can extract like this cool information right now. So we can get the ladder logic runtime, we can get the PLC type or the RTU type. This particular instance right here, we're looking at that Bristol Common Wave Micro PLC RTU, and that's actually what that thing actually looks like. Um, and the data in that data dump right there comes back in clear text. Like there's no auth, no encryption, no nothing, because 15, 20 years ago it was cowboy land. So you could just do whatever you want. And this is what we're doing.
Yes, indeed. Indeed.
um, yeah. And so we'll take that information, sort of run it through our standard fingerprinting engine, and then like pull the PLC numbers out, the vendors and up that stuff, and start to actually fingerprint this stuff pretty nicely once we start
Hmm.
to see this traffic. So
I
yeah,
love it.
it's a super cool protocol, and I love the simple stuff, even though it doesn't have all the auth and encryption. But like, it's like, yep, just send us
Yep.
info, and we'll tell you what we are. It's
Yep,
nice and
that's right.
easy.
Ask me no questions and I'll tell you no lies. I love
Yes,
the beautiful hex dump there as well. I like that.
I did.
So
That's my favorite. That's my favorite one.
yeah, yeah. And then on that note, Blaine, you were talking about how IT and OT is no longer just in the factory.
No, it is not. And
Dun
this
dun
is that this
dun.
sort of came up as like an organic like life experience thing for myself. It just so happened I just went through this. So I was working on some of the fingerprinting stuff coming through the queue that customers sort of send us, and we got one that said it was a flume water monitor. I'm like, oh, that's kind of interesting, and that's new. Didn't fingerprint it before. Turns out that it was um, like an actual in-home consumer thing, which got me wondering. It's
Mhm.
like, okay, well, most of us think of the standard smart home as these sorts of things, right? We have
Hmm.
lighting, we have garages and TVs and speakers and sort of all the stuff that us as humans touch and interact with all day. Like that is
Yep.
our standard smart home. We have our apps on our phones that interact with all this stuff, and we can,
Hmm.
we can have the Tony Stark house, right? But now we're starting to see a little bit more interesting devices make our way in. So if you move on to the next one is, well, what about more of an operational smart home where we they're still becoming these IoT devices, but they're not in the traditional sense of the interactivity of the standard stuff.
Hmm.
So because I had just gone through a life change and I bought a new house and I went from living in a house with city water that I don't have to care about the water levels. I am now on a solar panel system. I have well water. I have propane for heating. So now I have to care about how much my propane costs and sort of all that stuff. So I sort of lost all the conveniences of relying on the grid and the power
Hmm.
grid and the gas grid and all of that, where all the stuff that we were just talking about is taken care of in that industrial setting.
Hmm.
But now I don't have that in my house. I literally have a tank in my backyard and it has a fuel level on it. So it got me wondering, like, well, what are some consumer grade devices that are out there that are sort of appearing in the
Hmm.
wild? And these are the things that we could start to look at. In a traditional home, we have fuel tanks like the propane that I mentioned. We have electrical
Hmm.
usage. Most homes have these solar panel, the solar panels. All homes have these breaker boxes that you see down in your basement that you are not
Hmm.
supposed to touch ever. And then water
Right.
usage. You got water usage and then even quality.
Hmm.
As my home right now, like our drinking water is fine, but like we'll get to the point at the end, and I'll show you the amazing water system I have in my basement that's doing all the amazing work that city water used to do. And down below is the screenshot was the asset that kicked off this entire topic was, oh, we can now find a Flume smart home water meter, which is
I love it.
really, really, really cool. So,
I love
uh,
it. I love discovering stuff like that.
so the first part is all the fuel stuff. So I have a tank that size in my backyard, and
Hmm.
it's full. And it has on the little cap that you see, if you open up that cap, there's a little dial that shows the percentage of the fullness of the tank, the capacity.
Hmm.
And all it comes off of it is just one line that goes into the house, right into the furnace, and that's what is used to heat the house. And we have folks come by, fill it when it gets a certain threshold, and then stop when it doesn't. Um, and traditionally, there's sort of two ways that you can measure a tank like this. You can do it with magnetic sensors, which actually kind of connect to that dial that sits under that cap, or you can actually measure the tank by weight because the tank and the fuel inside has a predictable weight um, based on what kind of like fuel you're actually using, whether it's propane or natural gas, this, that, kind of thing. So um, if we move on to the next one, first the first device that you can actually buy as a consumer is the sort of Sentry tank monitor. Um, and that's the description that I pulled from the website. And so this is solar powered, awesome, batteryless, even better, 4G LTE propane tank monitor. So as I said, if you peel off that little cap that's on the top of the monitor, you're going to find a dial like that that's sitting right there. And that connector is actually a standard called the remote ready dial compatible sort of tank dial. And all you
Okay.
need to do is sort of connect that so you just slide it on the dial, and then the cord will go and sit and connect to the modem and the actual
Hmm.
sensor itself. And it's just magnetically sits on top of the tank. It'll collect power from the sun, and it connects over 4G and LTE, and will transmit the dial level that you see on the dial digitally up to the cloud. And then that cloud service then sort of, now we're in cloud territory where we know, all the security protocols and all of the IT, TCP, IP stuff. this cloud service has custom integrations. It's got a REST API, an MQTT. So it's opened the world of IT stuff, but for a very specific OT related device in my backyard.
Yeah.
Um,
Extremely specific. Yes.
it's extremely specific. And that's the magnetic version. There is another version of these tank monitors, which is on the next slide, which work on smaller tanks. So that little blue ring at the bottom of the tank is a weight monitor. So just by sitting that little tank on the pad, same rules apply as to all the other cloud devices. Now you have this, quote unquote smart. It's basically a smart measure for weight, and then as the weight sort of changes, it'll send the weight changes up to the cloud and then back down to your phone and everything else. So while these things are like not really like very huge like attack vectors from a security standpoint, it very well could be. It might not be able to like address like your home network devices, but if that is an ill-built or has low security protocols while it's sending data back to the cloud, if you could sort of hijack your way to the cloud, you have an entire customer base and PII information, and all that stuff just becomes another way in.
And there's the famous story of the what was it, the aquarium thermometer or whatever. Yeah.
There's always a joke. I think every episode we're like, why are we connecting this thing to the internet? Like whether it's a coffee maker or a fridge, and now we have propane weight.
Yep. It is propane, and underneath there is a propane accessory. That is.
Yep.
So it's fascinating, and this is just connected to your standard Wi-Fi, which is it's just crazy to me. How far we've come. I love it.
Oh, very interesting. So the next topic is electrical. Like I said, this is a very, very standard breaker panel box, sub panel box that everybody has in their basement. The main grid line comes into the house and then gets dispersed to all the breakers and then runs throughout the house. If you have a solar system, you'll probably have a similar box outside connected to the panels, where it's sort of measuring the power generation from the panels and then backfeeding into the sub panel itself with its own sort of cutoff and breaker. That would have its sort of own sensor too. So, but if we're just paying attention to this box, like there is no IP anything anywhere here. Like there's no way that we can understand the electrical signals moving in and out of these breakers or the main lines, unless you go and buy the thing on the next slide, which is a sense power meter. So you can, again, commercially available. Go to the website. You can grab this thing. And you can see it's on the top left of the breaker box right there. That white cord coming down is a little antenna, which is a Wi-Fi antenna. So it's automatically connected to the Wi-Fi. And then off the other side, you see these two little white clips that are sort of surrounding the positive and negative lines of the main power. That's actually measuring the current running through without actually being connected to the lines. So it's sort of like inductive. Again, all cloud connected, sending your electrical usage data up to the cloud and then sort of back down to the device. And again, now this is becoming more of a commercially available device. It's not necessarily like controlling it, but like we're getting eyes into this sort of information in our own homes now, where traditionally we're seeing this stuff in industrial environments, right? So convergence is coming for us in our houses.
I gotta say, I would be terrified to like connect that to those. I don't know how much voltage is running through there, but it's probably enough that I would kill myself if I did it wrong.
Yeah, it's wild. I was going through like the setup docs because they have the PDF online, and it's got like the pretty like marketing material pictures of like the cartoon guy, just like open your breaker box and then you connect it to. I'm like, oh boy, okay. Like I don't even. I think down the bottom it said in the answer, like, please consult a certified electrician to do this. Like, don't do it yourself, but
right. I love it.
And the last piece is water. Typically a lot, especially if you live around bigger towns and cities and municipalities, like you just don't have to care about your water. Like you turn the
Hmm.
faucet on and water comes out and you can drink everything, even in the shower water, all of that stuff. Um, but on more rural areas where I just moved to, I have this is my exact setup in my basement right now. So I have a well that's drilled in the back of my yard. The water comes in the main house and it goes through a chlorination system. It will go through a sulfur system. It'll go through a methane system, and then finally go through like all that is just all the house water. But then we have a dedicated line for the fridge and put eventually the faucet in the sink to actually reduce the heavy metals, so you can actually drink it. So there's a third
Hmm.
step. So not all of the water in the house is actually consumable by humans. You can't drink the bathroom water in the sink
Interesting.
because because it's actually not going through um, the heavy metal filter. So
Hmm. Hmm.
it's still up there. But again, we were so used to relying on the industrial systems of the water treatment plant that's down the road somewhere, like in the backyard of who knows where in the woods, that
Right,
have
right.
all of the Allen Bradleys and the Rockwells sort of doing their job with filters and pumps and levers and stuff to clean our water. And
Hmm.
now we don't have that anymore. Now we have all of this in the basement, and all of these lines can be a potential sensor point where I can
Hmm.
change my chlorination level, change the sulfur level, change the water softener level. Um, so yeah, it's just super interesting. But there are commercial devices that are starting to hit the market for water systems, which we'll cover on the next slide. Fortunately, like this is probably the bigger one, is just
Hmm.
a water flow and leak detection. Um, because potentially some of these systems are, water main breaks or something happens and like boom, basement gets flooded. Um, or you have like a slow drip somewhere if you're paying for water usage.
Hmm.
Something could happen there. And this is a very interesting device because this doesn't actually get put in line with the actual piping of the water. It just
Oh.
sort of like sits and wraps around with a rubber bracket band around the water meter itself. So if you do have a water
Hmm.
meter, it it's it does sort of induce a current where it can track that current level and then transmit that data up again to the cloud over Wi-Fi because it's all connected to Wi-Fi now.
It's all connected to Wi-Fi.
And it's got the companion app with the visuals and the notifications. But again, it's like $250 for this device. And it will actually tell you if there's a leak, because once the water flow changes like drastically, that's
Hmm.
when it could potentially send you a notification that water pressure drastically changed. Go find the leak. Um,
Right.
again, just another case of like the three main utilities that
Hmm.
we have in our homes are now being um, sort of covered with these sort of OT level
Yep.
devices that we can just buy off the shelf at this point.
The home OT,
Yeah,
the hot. Has
exactly,
anybody made that
exactly.
acronym yet? If not, it's me. I came up with that.
No,
Hot.
it's yours.
Home
You can
OT.
have it.
All right. All
You
right.
got to go put it on Wikipedia first, and then be
There
the
you go.
author.
There you go.
So
And I did not know that running water induced a current. Physics is magic to me.
yeah,
So
yeah, very cool.
so
Um,
and then
yeah,
so you're
so
just talking about all the sensors. Yeah.
yeah, and then so like beyond that, like that's just a flow detector. Like, and if we took like where I have my system now, like I imagine we're going to start seeing much more of these sensors that are
Hmm.
testing the intermediary stages of every one of these pipes and these filter systems, just like buy them off the shelf, and I can go and just put them in myself, right? And
Yeah.
I can change because I can actually control how much chlorine gets put into my water and how much it's pulled out, just to change the sulfur levels.
Hmm.
Um, and then that also has direct impact on some of the filters lifespan too. If there's too much
Hmm.
chlorine at one stage of the system, it's going to screw up the filter downstream. So I need to make sure that the chlorine levels has zero point 0.2 microns per drop of water of chlorine, um, which I have to just manually remember to go down and like try every now and then. But if there's a sensor before and after, it can just tell me when it's time to do this. So
Yep.
yeah.
Yep. It's all mad. Yeah. I rely very heavily on the grid is what I've learned.
Yeah.
So
Um,
So, and there's a
yeah,
looks
and
like there's a
so
blog post.
yes, that's sort of like, what wrapped up all this for us in general. Like when we were starting to talk about all of the OT IT convergence in general, like what you talked about at the beginning of all of this, we're seeing more operational devices, coming into the home. Like, yeah, meters are mostly passive. They're just like kind of telling us what's going on. They're
Hmm.
not actively controlling anything. So the risk of actually some outside attacker getting into one of these devices and screwing up your water or getting in and screwing
Hmm.
up your
Hmm.
electricity is like almost low, but like that it's a stepping stone up to the cloud data where there's
Yep.
PII stuff and more additional information.
Hmm.
Quite frankly,
Hmm.
like our home Wi-Fi networks, well, not ours because we're smart security people, are
Oh,
yeah, we don't have we don't traditionally have firewalls. The average human being doesn't have a firewall. They have poor passwords, that all of this stuff
Yep.
surrounding their home networks where we could just like passively drive by and,
Yep.
Wi-Fi scan, see if we can get in. And all of them are sitting on some cloud SaaS with all the customer data in the cloud. And we've seen break-ins and breaches constantly.
Yep.
So yeah, I
Well,
mean, it
as
seems to be it could be the next like logical step of like the
Yeah.
convergence that we've been talking about for months at this point. Like now it's everything is in the home. So
yeah, as Mark pointed out in the Q&A, like this stuff is going to show up in companies. And so
Hmm.
understanding that it's there, what it does, and detecting it with products like ours is going to be more and more important as time goes on. You already do
Oh
that
yeah.
with a lot of things that started off as more consumer centric that ends up in enterprises, things like thermostats or Apple TVs. Um, and another side of this is like, even though these devices might be intended to collect data and send it to the cloud, if it's on your Wi-Fi, there's a very good chance it's very chatty on the network. And so
Hmm.
um, that traffic may contain information that's useful. It may be leaking information. These may be devices that have a local web interface that's using some unmaintained version of a web service that if an attacker gets access to it, they pop it, it becomes a foothold. Definitely things we've seen in the past, as Rob talked about
Hmm.
with the aquarium. I think it was thermometer being
Hmm.
compromised and used as a pivot point. Like
mhm.
it's important for us to know that these things are there, identify them, include them in our risk models, um, and keep them up to date and include them in our security practices. So I love
Tom,
seeing being made more aware of these type of things.
what's the embedded web server that uh we did that deep dive on that is no longer
Is it,
supported? And
is it light HTTP? Is that the one? Or is it like
no, no, it was
Oh,
like
it's a
OK?
different
Speed.
one.
OK.
Oh,
I'll have to look it up. It's in the research report. We should go read the research report. But yeah,
yeah,
but
yeah. It's
but on that note, Tom, are you ready to round up the rapid responses for November?
yep.
Excellent. Take it
So
away, sir.
So what we have here is a list of some of the rapid responses that we put out over the last month. A lot of these have come out in the last couple of days or today. Some of these are still pending. And so I just wanted to sort of talk through some of these and raise awareness about some of the products here, and in some cases give some caveats where I'm aware of them. So the first thing on the list is the SolarWinds Web Help Desk. It's got a 9.1 CVSS score and basically allows remote unauthenticated user to access internal functionality and modify data. I don't quite, I'm not quite sure I understand what the breadth of that, what that means. Like, we talking admin access, we talking about system access. Can you get in and execute commands? It's sort of vague there, but there are patches available for this. And given that it's got a 9.1 um, CVSS score, is probably something we should be addressed soon. Um, and I don't think I mentioned it. This is due to hard coded creds. This is a thing. This hard coded creds vulnerabilities drive me insane. It's sort of a personal pet peeve of mine that such things shouldn't exist. I consider them backdoors in products, and they tend to make me a little grouchy whenever I'm dealing with vendors. I know it happens on accident sometimes, but some vendors tend to have patterns. But yeah, probably should address that sooner rather than later. The next thing up on the list is a 9.8 in FortiManager. And this is due to missing authentication in the FortiManager daemon that handles communication between firewalls and the FortiManager itself. It got a lot of attention whenever it came out. There were some write-ups by Google. Mandiant did some write-ups about it as well because they were handling cases related to it. But basically, what it boils down to is that there's a communication protocol that is used between the FortiManager and the Fortinet managed devices that's encrypted, and there is a failure in the authentication there such that an attacker can register their device with the FortiManager, and that gives them enough access to execute code on the FortiManager device. It's known to be exploited in the wild. I think Mandiant said that exploits go back at least to June 27th of this year. And it's definitely something that if you have not dealt with it already, it came out, I think, in the middle of last month. If you haven't dealt with it, you really should be jumping all over this because it's exploited in the wild. There was mass exploitation. I think they know of at least 50 devices that were popped on the general internet. And I wanted to give like a special shout out to Fortinet because their advisory on this not only contains information about the patches and mitigation controls, which is something you expect, but they also contain IOCs such as log entries you can look for and an explanation that once you patch, those log entries may still be there, but they just indicate that somebody has retried to compromise your device. They also include IP addresses and files and things like that were collected from things like Mandiant's report and Google's documentation where they have seen these things in the wild. I really like it when a vendor not only says, here's a fix for the thing, but here's how you can tell your thing has been compromised. And that goes a long way to like helping folks identify whether or not their device needs additional attention past just patching it. And I really like that when I see it from vendors, when it's good data and it's maintained. Occasionally see vendors do it in poorly, but this looked good. I appreciate that from Fortinet. So the next item on the list is Rockwell's Factory Talk Thin Manager. And as I understand this is like Citrix, but for IoT. As I understand this product, basically you have all these different interfaces and terminals for devices in your environment. And this gives you a way to abstract that and provide that information back out to, say, mobile devices or desktops. It's just like a thin client. And there are two vulnerabilities in this product. One's a 9.3 CVSS score, and it results in potential DB manipulation. So basically, you can bypass authentication and make changes to the database. And the other CVE is 8.7. It's a denial of service. If you can talk to the endpoint, you can basically shut it down. And if you think about people trying to manage OT environments and suddenly you take away their eyes and their ability to control system, that's pretty serious. So denial of service in some cases is sort of annoying. But in a case like this, depending on what's being managed, it could be pretty serious. And so there are patches available for this, and it's something folks who use this Rockwell software should definitely look into. The next one is Citrix virtual apps and virtual desktops. So for those who don't know, Citrix most of their products revolve around providing remote desktops and directly publishing just applications to end users, so that you've got desktops or software running in your data center, and then users across the world or in different offices can access them. And this is vulnerabilities in that system that result. They're rated as 5.1 CVSS scores, but if my understanding is correct, I really think that one of these should be much higher. So the first one is, according to Citrix, authenticated users, people who already have access to the system, can escalate their privileges to system. That's bad. It's part of how the system operates. Like, it's one of those things where he's like, okay, I get why this was in the code, but the fact that an average user can get there is the problem. So to me, that's, if you can phish somebody's credentials and get into the application, you can then elevate the system and take over. There were some references there to being able to impersonate other users as well and shadow desktops. That's pretty serious. It feels to me higher than a 5.1. I feel like their mitigation there is like, hey, you have to have creds, but come on, folks. There's a lot of phishing that happens, and if you don't have MFA, one, get MFA, but two, like, that elevates the risk related to this. And it's always important to keep those things in mind when you're reading a CVSS score, that they may be factoring in controls that you don't have in your environment, and that you may need to escalate the priority of addressing some issues. The second thing inside the virtual apps one is, according to to Citrix, authenticated VDI users can execute remote code as the network system account. And this is also a 5.1, which I kind of get. Again, they're probably saying, hey, you have to have creds, and two, you're as network system, network service. And that's kind of limited. There's limited things you can do with a network service account. And then the challenge here is that, or my issue that I have with the rating here is that the Watchtower team did a fantastic write-up on this. Like, they always do good work. I've seen multiple write-ups from them in the past. They're outstanding. In their write-up, they say this doesn't require authentication. You can, as part of the installation, this exposes on the one of the components on the network, doesn't require auth. And that, to me, sounds more serious than what has been exposed here. So I feel like there's some miscommunication there, or I'm misunderstanding things, but that's to me something that if you run Citrix, you should definitely address these really quickly. Kind of running short on time here. You can see the other items here for the Palo Alto Networks Expedition patches. There's a PanOS vulnerability that's RCE via the management interface. Not any real good details there yet. Like, they're still collecting information there, but in general, don't allow your management interfaces to be on the internet or on untrusted networks. And then some additional entries there for FortiManager and FortiOS. Those two are pending. They should be up like by the time this webinar is done. So just look forward to those.
Thank you so much, Tom. And yep, check out those blog posts. They will tell you how to find these devices using runZero. I love our rapid response stuff. I love it. I mean, you can tell I'm full of love, but I really do. I just love everything we do. It's so great. I love it. And thank you, Tom. Thank you. So moving on just real fast, I highly recommend you check out our illustrious fearless leader, HD Moore. Was featured on the Risky Biz podcast. I recommend you go check it out, where he's going to talk about, or he talked about, the Insight Out attack surface management, which is this fascinating idea of when you can fingerprint devices really, really well, you can tell when that device is visible, even when it's on a different IP address in the public internet or wherever. And by the way, we fingerprint devices really, really well. I love it. So definitely go check that out. It's a really fascinating podcast, and HD is always great to listen to. And then finally, the big news. There is the chance to win a mystery mini machine built by the aforementioned HD Moore. If you subscribe to the runZero Hour, you can also you can enter a raffle to win the mystery mini machine. And the first 150 subscribers can get a limited edition runZero t-shirt. And it is a cool t-shirt. So, I mean, I have great fashion sense, as you can tell, because I'm wearing a runZero shirt already. And now you too can wear a runZero shirt. That's really cool. So definitely check it out. And then join us for the anniversary episode of runZero Hour on December 11th. So I look forward to that. Thank you so much, everyone. Tom, Blaine, thank you for all the insights. I hope everyone has a great day, and I hope to see you all next month. Thank you so much.
Thanks, everybody.